In this video lecture, we are going to learn about transformers. So a transformer is a device that uses the principle of electromagnetism to convert one voltage or current to another. This device is used especially while designing power supplies in electronic projects or electronic systems. And in electronic projects especially we use step-down transformer. So here are few diagrams of few pictures of different types of transformers. So now we will understand the basic principle of transformer. So transformer works on the principle of mutual induction. As you can see, there is no physical contact between this winding and this winding. So in this diagram you can see this is a transformer core on which we wind our wire. So in this side we have more number of turns, as you can see, and here we have less number of turns. So this is basically a step down transformer. In step down transformer we decrease our input voltage. So suppose at input side we have 220 volt and we want 10 volt at the output side. So this is called step down transformer, and to decrease the amount of voltage we round less wire on the secondary side. So here you can see we have less number of turns as compared to the primary side. And we already know the total power remains same both the sides. If it is a 600 watt transformer, power will remain same both the ends. At the input side also power will be 600 watt and output side also power will remain 600 watt. Only values of voltage and current changes according to our need. So if at the output we need less voltage, suppose 10 voltage, then current will increase to keep the power same. And in input side we have more voltage, so current will be less. So now how does it work? How does it produce voltage here at the secondary winding? So here you can see when we supply voltage to the primary winding, there is a current, and because current is flowing in this coil, a magnetic field is produced. So as the input voltage is AC type, magnetic field also be alternating. It will also be changing with time. So as magnetic field is changing with time, so when it touches this secondary winding, when the conductor of this secondary winding cut this changing magnetic field, an EMF is induced in the secondary winding also. So in this way, through mutual induction, the voltage at the secondary winding is also developed. So this is the basic principle of transformer. It generates voltage at the output side through mutual induction. Here we have different types of transformer. The first one is step down transformer. So this is the most widely used transformer in our electronic projects, where we need to step down the input supply to another voltage, be it 12 volt or 10 volt according to our application or our need. So here you can see this transformer. Here we have two wires, and here this side we have multiple wires. So this side is primary and this is secondary side, and this is actually a center tap transformer. So suppose we have 12012 written on the secondary side. So this 12012 means the first wire, if you connect this first wire, and this middle one is for common wire, and third one is also 12 volt wire. So if you connect your load between this first and second wire, you will get 12 volt. And even if you connect your load between the third and the middle wire, then also you will get 12 volt. But if you connect your load between the first and the third wire, both are the 12 volt wires, so in total you will get 24 volt. So this gives you the freedom or the flexibility to choose your output voltage according to you. It gives you different options. So if you want to use only 12 volt, connect your load between first and the middle one, and if you want to use 24 volt, then connect your load between the first and the third wire. Then here we have 606 also, so the other wires gives you the other options. So here 606 means the same, the first and the third, first from this side, first and the third will give you total 12 volt, and if you connect your load between the first and the middle one, then you will get only 6 volt. So you have different options available at the secondary side. So this is center tap transformer, and we also call it step down transformer, which you can use according to your need. Isolation transformer has 1:1 turn ratio. 1:1 turn ratio means it has equal number of turns in the primary and in the secondary winding. So as the number of turns are equal, so the voltage at the primary and the secondary side is also equal. So the question arises, then why do we use this isolation transformer? So we use this isolation transformer to separate or isolate the load from the source. So in some applications like in medical instruments, we want to protect our medical devices which are connected with the patient. So in that case we use isolation transformer. So suppose if there is a AC power leakage in the source, that doesn't damage the medical instrument or medical device. So it protects the medical instruments or any device that is connected at its output, it protects that. That is why we use isolation transformer. It is, you can see in the diagram, it isolates the two devices connected at the source and the load electrically. As we know that there is only magnetic linkage in a transformer between the input and output side, there is no electrical connection, there is only magnetic linkage. So it provides electrical isolation between the source and the load. And it is also used as a surge suppressor. So what is surge? Surge is a sudden rise in the input voltage or AC voltage. So whenever there is sudden rise in the voltage, it will protect the load against it. And it also gives you the noise filtering. So it will remove the noise coming from the source and it will protect the load. Here in this diagram you can see they have mentioned PRI. PRI means primary winding. So it has 230 volt rating. Secondary winding also has 230 volt rating. And total power is 100 VA. Power we find out with the multiplication of voltage and current. Voltage unit is V and current unit is ampere. So they have mentioned VA here. So power will remain same, both input output, and also the voltage, primary and secondary voltage is same at both the sides. So this is isolation transformer. Here we have another type of transformer which is impedance matching transformer. These are the special kinds of transformer that are used to match the impedance of source and the load. And sometimes we have such systems like public address system where we have a mic and a speaker. So we transfer the electrical signal from mic to the speaker so maximum people can hear it. But the impedance doesn't match there. Mic has very low impedance and speaker has very high impedance. So in that situation where we need to match the impedance of input to output so that maximum signal can be transferred to the output side, there could be maximum power transfer. In those areas we use impedance matching transformer. So it will have different number of turns at the primary and the secondary side. So in this way it will match the impedance of source to the load. So they have wide range of operation. They can work on a wide range of frequencies. So they are extensively used in the radio frequency range and radio frequency circuits, and for audio frequency range in audio frequency circuits. Next we have auto transformer. This is a special type of transformer that has only one winding. As you can see in the diagram, there is only one winding with a tap. So you can move this tap and change the secondary voltage according to your need. So this tap is somewhat like voltage divider. So it will change the output voltage according to your need.